Inductive reasoning and finding the nth term. So definition first of inductive reasoning is the process of observing data, recognizing patterns, and then making generalizations about those patterns. So some examples could be like trial and error. Okay, y'all do this in your science classes, right? And then you come up with a generalization. What do y'all call that? Hypothesis, right? An educated guess, right? Is that what it's called? Like an educated guess. So using like past experiences, seeing what happened there. Okay. Also making discoveries by noting some similarities. So you're going to actually use inductive reasoning to figure out patterns. Okay, maybe of numbers or maybe of pictures. Okay, we're going to actually do an investigation here in a little bit, and we're going to use inductive reasoning. Be able to define and tell me what inductive reasoning is also, because we're going to do deductive reasoning tomorrow, and you're going to have to know the difference of the two. Okay, and there is a difference. Maybe you know it already, maybe you don't. But you will know after tomorrow the difference between the two. All right. Ready to put this slide down? So your generalization, sometimes there could be two different generalizations based on what's given. Okay. Sometimes you can have two different, ending patterns, and it just depends on what it is. Okay. So if you have good, reasoning behind it, saying this is why we should do this. Now there's some that you still have to go with the correct patterns. Okay. All right, let's go on to the next one. So when you use inductive reasoning, you come up with that generalization. It's just called conjecture. Okay. So you'll hear me say come up with a conjecture. Okay. All it is it's that generalization. Okay. Conjectures are also known as theorems. So like technically like the Pythagorean theorem. Well, all these geometers way back in the ancient times, they came up with that conjecture. They figured out like, oh, a squared plus b squared equals c squared all the time. After doing, so many different investigations. Okay? So that was their conjecture. So then they turned it into a theorem. Okay? Okay? So being able to come up with conjectures, okay, or being know what that means. Okay, so let's practice using some inductive reasoning. Okay, go ahead and draw that pattern out right there. Draw it out. Put investigation and draw that pattern out. Okay, as you're drawing it out, think about what's happening here. Okay. You've got 1, 2, 3, 4, 5, 6 pictures. That's the start of it. And then use inductive reasoning to draw the next 2 figures. Then perhaps the 25th figure, and then the 30th. Okay? Do your best to draw it. If you can't draw it, that's okay. what is the next figure gonna be, huh? Alright, good, so the circle, and then the right side is shaded, good. So they went top, left, bottom, you have to read me, it says we're going to go to the right, okay? And then the next one? Nine-sided figure, so 1, 2, 3, 4, 5, 6, 7, 8, 9. Alright, now do that, and then you have to have those dots in there, right? Close one there, open, open. Okay, so nine-sided figure. What's the 25th gonna be? Why do you know how do you know it's gonna be a circle for sure? Right, very good. So here, this is a good inductive reasoning strategy to do is number these. First picture, second picture, third, fourth, fifth, and sixth. Okay, so it's good to number them. So yes, all the odd, and then what do you say? Shaded where? Top. Okay, so let's double check. Okay, what if I told you to find the 1027th one? With the left side? How do you know it's the left side? So the 1025th will be the top for sure. Think so? Okay, so let's double check. This is a good way to check and use some more inductive reasoning. So the first 5, 7, the first 4 are all the different pictures, right? Shaded on top, shaded on left, shaded on bottom, and then shaded on right. Okay? And so then this is 9 and 11 and 13 and 15 and so on, right? And so in every 4, we have 4 different pictures, but they're all odd numbers. How many odd numbers are always in a full set? How many odd numbers are always in a full set? In any set. Half, thank you. Okay? So like in any set that continues, it's always going to be half because there's half even and half are odd, right? So what you want to do is you want to take that number. So let's just practice on the 25th. So you take that number, 25, and you take half of it, divided by 2. So that's 12.5, right? You don't want to do it half a picture, so you now just drop that off. Okay? And then you take 12 and divide by how many things? 4, right? So you divide by 4, and it goes into it evenly, okay? It goes to it evenly, you have no remainder, right? So remainder of 0. So then that means it's back to the beginning, okay? So if it goes into it evenly, it's back to the beginning, all right? So then that's the top shaded, right? And so 15, 17, 19, 21, 23. So see how 25 this is back to the beginning? Okay. So then for 1027, you take half of that. Can you help me with that? Half of 1,000. 5. So 513.5 is drop the decimal and divide it by what? 4. What? That we have to actually do the long division because we want to see the remainder. So it goes into 1. I'm sorry. 1. Bring down the 1. Hold on, we got 1 decimal. So 3, 8. So 32 remainder of what? 1, right? So then that means it's going to be this one. So now we got that? The one-sided? One-sided shaded? So the 1027 27. That makes sense? Our top. You're ready to what? It was the next, yeah. There you go. Yeah, and then we'll start back over. Yeah, good job. Okay, so he said if you're dealing with, guys, listen, Matthew, you know I'm trying to talk. If you're dealing with the thousands and the 2,000s and the 3,000s, you can just get rid of that and work with the 27. Okay? All right, and the 30th figure. 31's on, right? So don't expect y'all to draw that. How do you know what the 31's on?
The 30th 16.
Or
You would have to say 4 and 5, 6 and 7.
that's roughed up. These right here are always even, and it's always one more, right? So you just add one to that. So there's one more thing. All right, good. Okay, next thing, mathematical models. Write that down, mathematical models. We'll use math models. It's basically just the use of inductive reasoning to find the patterns in a sequence of numbers. Okay? Now, this sounds all, fancy, but you did this last year in Algebra 1. Okay? You found the pattern in a sequence of numbers, and they were actually different types of relationships. Can you name one, Ian? What kind of relationships did you study last year in a sequence of numbers? Starts with an L. A linear relationship, okay? Because that means it's going to constantly what? Go up or down by the same amount. What's another one? Exponential. What's another one? Quadratic, right? Yeah. Now, so you work with linear, compounding ways. You work with linear functions, quadratic functions, exponential. You're going to do work with them again, okay? It's slightly different, okay? You're going to find a function rule, which y'all called that last year an equation. Okay, there's an equation to every pattern. You're going to write the rule down. Okay, that means the same thing as finding the nth term of the sequence. So if you want to write down that the function rule and the nth term is the same thing as the equation, okay, of the function, you can write that down also. Okay, because you technically did this already. So in your homework, if it says find the nth term, that's all it means is to write the equation out. Okay? If it says to find the function rule, all it means is tell me the equation. Okay? All right, so make sure you wrote down function rule and nth term is the same thing as equation. So let's practice that a little bit. Okay, you don't have to write these two down, but I want you to write the next two down. And this is a pretty easy pattern. This right here is an example of the nth term. Okay, the nth term is n minus 5. Right? Or the function rule. And so if we're going to continue this pattern, what's the slope of that rule? The slope. Well, you work the slope up to how you go. 1. What number is going to be in front of it? 1. They don't have to write it. So the slope is 1. That means it goes up 1 every time. Okay? What does the negative 5 represent? So right here, that would just be negative 1, 0, 1, 2. Okay? So you'll have to find the pattern on your homework. I'm going to make that easy. I'm going to say find the 100 term. Okay? You always start with the first term. I know in Algebra 1, you started with the 0. Okay? You start with the first term when we talk about patterns. Okay? Over here, what's the slope of this function rule? 4. Just 4, not the n, just 4. And then that means it's going up by 4. So this is 13, 17, 21, 25, and alright? Be able to find a very, very large one. So you can use the calculator. Okay? Just put it in the calculator and it makes it a lot easier. Anybody on there Inspire? Anybody on grab the calculator twice. I'm just saying that's the biggest complaint that I've heard all year. I only have the Inspire. That's all we used last year. Okay, so if you have your own Inspire, you can use that. We don't have it in yet. Okay. out, big fancy table, just write 1, 2, 3, 4, 5, 6, 7, 20, 27, 34, 41, 48, 55, 62. And then I want you to write down the nth term. Write down the nth term. Also known as the function rule. Raise your hand as soon as you got it. You got it. All right, got it? No? Tyler, you got it? No? Donnie? Got it? No? No, no? Adam? No? Eric? Not yet? We're really thinking with you arms up. Okay? Niall. Alright, put your hands down. Niall. What you get for the nth term? 7 is plus 13. Who else got that? Alright, that might be right. Okay, so you have to take time to algebra 1, figure out the differences. What are the differences? Okay? These are all numbers. Those are all ones, okay? So then you do like the change in y over the change in x. We're talking about something. Do the change in y over the change in x, okay? Or right over right. And so you get 7a, so there's your scope. And then to figure out the y intercept, just kind of take it back a line, right? And so it's back to 7, right? Is that what y'all did? Yeah. Okay. Now, if they give you a weird pattern, okay, like I'm going to give you a weird one on your homework. It's not going to be 1, 2, 3, 4, 5. I might give you 1, and then I might give you the 5th one, and then I might give you the negative 3rd one. Okay, all out of order. You may want to rewrite it like this. Okay. Okay, one more. Copy the 4th one down. Last one. Copy this last one down. 1, 2, 3, 4, 5, 6. 5, 6, 8, 11, 15, and 20. This one's tougher. Write it down, Eric. Write it down. Write it down. If you get the equation, your hands up. You can find the nth term. Ian, what'd you get? Nope. Okay, so I'm not sure if you're. Okay, so I'm not sure how your people are talking about school for this last year, okay? But what you want to do is what we did is like we go is take the percent differences. Hold on. So what does this go? Okay. Would you say that that's a linear function? say that your function is constant, okay? Well, what happens when you take the second set of differences? Okay, so now you get a constant increase after the first set. When that happens, okay, again, I don't know where my teacher told you this. When that happens, that means it's what type of function? Not linear, it's quadratic. So write that down. But second set of differences is constant, that means it's quadratic. Okay, it's a quadratic function, meaning if I were to grab these points, okay, we'd end up having what type of picture? A parabola, okay? Or an arc of some sort. So the way you get the equation is, I'm going to just show you in the calculator, so go get your calculator. Hurry, quickly, quickly. Alright, here we go. Stop talking. Here we go. Everybody clear your memory. Okay, press second plus 712 till it says RAM clear. Okay? I'm going to start with the French calculator. Okay? Second plus 712. Okay, you're going to want to practice this right now because again, y'all used Inspire last year and you may not know how to work with this one. So, in the Inspire, you were able to punch in a table, and then it spit out an equation for that table, right? That's what we're going to do here. So where you do that is you press stat. It's right under delete. So press stat. Okay? Then you go to edit by just pressing enter. So you go to edit. You want to make sure you have L1 and L2. Does everybody have L1 and L2? This one is 2. All right, now right to your table. 1, enter. 2, enter. 3, enter. 4, enter. And let's just go to 5. Then go press the right arrow and put your other values. 5, enter. 6, enter. 8, 11, 15, and then that's it. Okay, so we're just going to do the first 5 terms. And really that's all you need. You can probably do 4 and it's going to be okay. Okay, so everybody has the table in. If you have a different amount in one column versus the other, then it's not going to work. So you have to make sure you have the same amount. Alright, so then once you enter the table, under edit, you're going to write that down. Then you're going to go back to stat. Everybody go back to stat. Then you're going to go to calc. It's the right arrow. That means calculate. We want the calculator to calculate something for us. What do you think? Fine. What if we wanted to calculate a linear function? What would that be? 4. Okay. So then you just go down to 5. Okay. So put, I'm going to describe as linear or quadratic. And then press enter. And then you have a blank screen. You have to press enter one more time. Okay? Press enter twice. So there's your end rule right there. Okay? So it looks like this. 0.5 n squared minus 0.5 n plus 5. Okay, that's your nth term. It's a quadratic function. Okay? So Inspire did the same thing for you last year, right? Okay? That's all it is on these right here. I don't know what you're thinking Inspire, so you just have to know how to use the stat function. and look at these notes, which will be posted on my webpage.